Thanks very much for the invitation. I want to thank the Environmental Commissioner's Office for setting up today and inviting me to participate and to present to you. Before I jump into my presentation, I want to take a minute to just provide a little context for my talk. First and foremost, I should point out that, as stated, I'm with Environment Canada, and specifically with the Science and Technology branch and the Climate Research Division. So I point this out not because I thought everyone would particularly enjoy a walk through the Environment Canada org chart this morning, but just to give you a little bit of background and context for where I'm coming from in putting this talk together. So climate data writ large involves multiple players from various different branches and sections within Environment Canada. And for this talk, as others have done, our colleague from the City of Toronto, I pulled in input from different colleagues in different sections and branches. So I'll try to highlight the key aspects of EC's work related to climate data. But I'm sure, as we're all aware, it gets fairly challenging to fully cover the work of a large organization in a setting like this. So given the goal of today's roundtable, I'm going to focus on the work that we do specifically in the areas of historical climate data analysis and also future climate projections and scenarios, specifically as it relates to our goal of supporting adaptation in Canada. And so Environment Canada's role, we see it very much to provide the foundational scientific climate data, information, and research. And we work with many domestic and international research partners to carry out this function. We also rely quite heavily on collaborations to provide the so-called value-added climate information or climate data products to end users. And this theme has come up already quite a bit this morning in talking about the translation function from the climate data and information to the end users. So the concept of working in collaboration is very key to our work, especially when you think in terms of moving from the foundational research, monitoring, modeling, through to the user-specific applications. So the graphic up here is a little bit of a representation of what I like to call the climate information value chain. And it's not perfect in terms of a schematic here. There's probably some areas that would be better represented as kind of overlapping or even blending into one another, but it just kind of gives you, at least my idea, of where the key players are and what are the key elements in each area. So EC's role as a provider of foundational climate data involves network design and operation, data management, analysis and dissemination, and research, modeling, and scenarios development. Of course, we're not the only ones doing this. Again, we've heard, I think Ryan mentioned it, there are monitoring networks at different levels of government and even in the private sector. And certainly there are many Canadian academics and internationals that are quite extensively involved in climate research and, and modeling as well. And in fact, you're going to hear later on from a professor at the University of Toronto, Professor Pelche, will talk about some of his research here. But Environment Canada is the primary agency with the mandate to do this work at the national scope. We do provide some what I call tailored climate data products, but as we move more toward the targeted products and the user-specific applications, we really look to other Government of Canada departments and agencies and build collaborations with these other departments that work more directly with the regional and sector-based end users. And of course, we have some representatives from the various regional climate consortia, and we've heard a little bit about them already this morning. We really look to them as a key partner in this sort of delivery and translation mechanism again. So with that overview of kind of where we see our role in terms of supporting adaptation, I just want to talk a little bit and highlight some of the climate information that Environment Canada does provide. As I said, we operate a network of monitoring stations across the country. The network primarily supports the operational forecast capacity, but it's also essential to look at long-term climate monitoring. And EC is responsible for maintenance and operation of the monitoring network, as well as the research side that we develop what we call adjusted and homogenized climate data records to study long-term trends and climate variability. So long-term data and derived data records are essential for studying climate change and variability. But monitoring stations are primarily designed, as I said, to support the operational forecast. So it doesn't really matter all that much if you take a station and you move it, or you plant a big tree next to it, you move it from the sun to the shade, things like that. But those kind of things can have a pretty big effect when we're talking about long-term climate monitoring. And in fact can introduce some fairly serious negative impacts, what we like to call apparent climate changes or shifts that are not actually climate related. So of course the ideal solution would just be to go back in time when we're aligning the monitoring network, putting in these stations and say, okay, we're going to put these stations here really to help forecast the weather. But down the road, we're really going to need to look back at this data to get a good idea of what the long-term climate is doing. So please don't ever move the station, don't plant a big tree next to it or build a big building. But unfortunately, the BBC isn't really keen on lending out the TARDIS these days. I emailed them and asked. So we have to find other ways to do this. And one of those ways that my group is quite extensively involved in is developing and using statistical techniques that are well recognized within the science community. And I know that David talked earlier about scientifically defensible methods, and of course we're really big on that as well, to produce, as I said, adjusted and homogenized climate data. And of course, consistent with our overall research program, this work is done quite collaboratively with both Canadian and international academic communities. It removes the artificial changes that can be introduced by the non-climatic factors I talked about before, and allows us to assess long-term trends and long-term change. We can also produce gridded data sets, and these have been mentioned again this morning, for specific regions or the entire country. And this allows us to assess these long-term trends at regional and national scales. Another benefit of gridded data sets is it allows us to assess the climate models. So we can look at the model skill in replicating historical climate because, as you know, climate models don't produce point source data. So in addition to the work that we do developing the adjusted and homogenized data records, we're also involved in climate change detection and attribution studies. We develop reanalysis data sets. We provide input to building codes and standards, again ties in with some of the other talks that we've heard already, and develop climate indices and long-term trends for agroclimate conditions, among other things as well. One of the, what I like to call data products that we do provide directly to Canadians is the Climate Trends and Variations Bulletin. This is based on, again, adjusted and homogenized Canadian climate data, and it presents essentially recent climate conditions in the historical context. So temperature and precipitation trends are given for the country, and as well it's broken down by 11 climate regions across the country. It's not by territorial or provincial boundaries. So another key element of climate information and the work that we do here is in climate modeling and scenarios development. Environment Canada has developed a number of climate models of our own of varying complexity, from atmospheric general circulation models up to our coupled Earth system model. And we provide a range of future climate information based on the results of our own models, as well as from multi-model ensembles that include information from many of the climate modeling centers around the world. Environment Canada right now has two main ways of disseminating this information. One is through the Canadian Centre for Climate Modeling and Analysis website, and you can find model results from Environment Canada's own models. You can download the data files, look at model output from various experiments, various models right there. We also have climate change scenarios, which are available from the Canadian Climate Data and Scenarios website, and I'll talk a little bit more about that in a minute. So EC's climate research program, we've already talked a little bit this morning. I know Ryan mentioned it in his talk about the IPCC process. Specifically in terms of climate modeling, we're active contributors to the CMIP experiments, which is the Coupled Model Intercomparison Project. I'm sure many of you are familiar to some extent with that. It's basically the set of models that drives the IPCC assessment reports. And again, back to the theme of collaborative research, our scientists are engaged in many research initiatives with Canadian and international researchers and academics and other governments. It includes work with the World Climate Research Program and a whole lot of model intercomparison projects. We've also developed a regional climate model, which of course provides future projections at a higher spatial resolution than what we get from the global model. So what we're looking at right here is running through projections of surface air temperature change relative to the 1986 to 2005 average from our Canadian Regional Climate Model version 4. It's at 50 kilometers resolution and driven by the RCP 4.5 scenario. So this particular animation and others for the North American domain from our regional climate model are available on the Modeling Center's website. You can also we've done experiments over the European, African, and Arctic domain for various climate parameters and driven by different RCP scenarios. There's also animations for global projections from the global models, again, for various climate parameters and different RCP scenarios. So many of you will be familiar with the Canadian Climate Change Scenarios Network website. And if you visited that site recently, you also know that we are in the process of kind of converting it from the old CCCSN website architecture to what we're calling now the Canadian Climate Data and Scenarios website. So many changes have already taken place on the website to bring the look and feel in line with the current Government of Canada standards. And right now our main focus is upgrading the scenarios based on the multi-model results from CMIP5. So I don't remember exactly who it was, but someone earlier this morning pointed out that a lot of the scenarios that are available are still the older SRES scenarios from the fourth assessment report. And so one of the big focuses for us right now is to update the scenarios using the CMIP5 multi-models and the RCP scenarios. Ultimately, we're going to include some of the historical data also on this site that I talked about earlier. And over the past about 2 years or so, we've conducted various different user consultations to look at and identify a more user-friendly way to organize the site. And now we're kind of shifting it towards, again, something that was already talked about in the context of the guidebook, the scenarios guidebook that Uranos published, which is different tiers of user information. And so I like to think of this more in terms of tiers of user information, not necessarily tiers of kind of users, because of course there would be certain instances where you could have a very advanced user who only requires sort of entry-level information for a particular application. So in that context, entry-level information would be things like pre-made graphs, plots, animations, tables, and also accessible plain language explanatory text. So that kind of thing would cover things like the utility and origin of various scenarios. So which RCP scenarios are driving this particular projection that you're looking at. Some things around the use of using multi-model ensembles and uncertainty in the projections, just so that kind of users have a little bit better understanding of exactly what they're looking at. The intermediate information tier would be geared towards those who want more customized information. So you could go to the site and put in specific geographic location and a time period of interest and then download the resulting data. And as I sort of alluded to before, this already exists on the site right now, but it's mostly with the older AR4 SRES scenarios. So one of our big drivers right now is to get the multi-model CMIP5 RCP driven climate change scenarios on to this website. And then finally, the advanced, or what we sometimes like to refer to as the power user tier, will offer a means to generate and download data files for future climate scenarios. So this tier of information would be more geared towards people who have a fairly significant or sophisticated understanding of climate change scenarios and their own particular needs right now. It'd be offered in the sort of industry standard data formats for those who want detailed information to drive their own applications. So things like crop models or hydrologic models, things like that. We've also talked a little bit this morning already about downscaling climate information. So downscaling allows us to project trends in various climate variables and value-added products into the future. We can analyze projected changes in return periods for climate extremes. For example, if we have a rainfall event that's a 1 in 50-year event right now, we can start to look at what we project the changes for that 1 in 50-year event to be in the future. We can also assess projected changes in certain indicators that are based on threshold crossings. So for example, we can analyze projected changes in an indicator like the number of days per year that a given temperature will be below or above a certain threshold. And from that, we can start to look at things like projected changes in heating and cooling degree days. In fact, Environment Canada has worked with the Pacific Climate Impacts Consortium to develop statistically downscaled climate scenarios based on various global and regional models, and the projections for Canada are available through the PKIC data portal right now. So the last slide I want to leave you with is a summary of some of the Environment Canada climate information and where it can be found. And some of this I've talked about, some of this I haven't really focused on too much. And so probably one of the first things you notice is that that's, should not just be one website. And maybe it should. But one thing I want to focus in on, certainly one initiative that I want to point out is the Government of Canada Open Data Portal. So this is a current initiative to make Government of Canada data easier to find and use, sort of like a one-stop shop for government data. And right now you can find climate station data. You can also find some of our Canadian gridded temperature and precipitation data sets on the Open Data Portal. And of course, there's plans to continually evolve and expand the portal to include more data. So in terms of supporting adaptation in Canada, Environment Canada really looks to provide the foundational climate data and information. Right now, much of that is sort of on a self-serve basis through our various websites. And as I mentioned, moving towards these sort of targeted data products and user-specific applications, this sort of translation function that came up at my table. I'm sure it came up at a lot of the tables this morning in our first breakout session. We do some of that work. We really look to kind of leverage the collaborations that we already have and also develop new partnerships moving forward so that our information is as relevant and accessible to the broadest user community as possible. And so, of course, I look forward to discussing with many of you through the rest of the day different strategies, different ways that we can use to kind of make that possible. Thanks.